Okay, so this is the sixth and final video for chapter 18 on the blood. This is not going to be a terribly long video. I just wanted to take some time and go over the last two slides about blood typing. This is also a concept that you guys are working on in lab. So you have seen the activities in the lab manual. You have also probably tried to play that blood typing game that's linked in that manual as well, and worked through some practice problems on your lab quiz as well, on the first lab quiz on blood. So this is not new, hopefully, but it can be a little bit confusing. So I just want to kind of run through what we're talking about here. For the A, B, O blood groups, we're talking about surface antigens. So glycoproteins that are extending out of the surface of the plasma membrane of the red blood cells. They're used for cell recognition. Okay, so it's normal for them to be there. Some people have one type of antigen on their red blood cell surface, and that's type A antigen. So in this picture, it's this little round purple one that indicates that you have antigen A on your red blood cell. It's just a surface marker. It doesn't do anything except for identify that those are your cells, for our purposes. So the other type would be B. Okay, if you are type B, if you have type B blood, that means that you have the type B antigen on the surface of your cells. It just says, hey, I'm B. These are mine. Recognize that this is self. It's just a way to sort of distinguish yourself from your non-self. It's a surface marker on your red blood cells, and you have type B. If you have both types of antigens, then you are type AB. So your blood type is named for the type of antigen that you have on the surface of the cells. It's just an identifier. Okay, think of it as a name tag. So type A, you have A antigen. Type B, you have B antigen. Type AB, you have both types of antigens. And then type O, you have none. So you do not have any of those antigens on the surface of your red blood cells. So the next step that makes it just a little bit more complicated is that you form antibodies to the antigen that you do not have. So the easiest way to think about this, again, is that it is self versus non-self. So if you are type A, you have A antigen on the surface of your blood cells. You're going to make antibodies against the other kind of antigen that you don't have. So you're going to make antibodies against the B antigen. So if you are type A, you have A antigen on your blood cell surfaces, your body will make antibodies to fight against the B antigen. So you have anti-B antibodies in your blood if you are type A. The reverse is also true. So if you are type B, you have B antigen on the surface of your cells. So you look like this guy here in this picture. You've got these little triangles. Okay, it's just a representation. So B is self, meaning that you are going to make antibodies against non-self. So A, right? So you're going to, if you're type B, you have B antigen on the surface of your cells, you are going to make antibodies that protect you against the A antigen, anti-A antibodies against the A antigen, okay? So an antigen is a substance that causes an immune reaction. An antibody is a substance that fights against that substance that causes the immune reaction, so the antigen, okay? So antibodies are the immune response. Antigens are the compound that induces the immune response. So let's keep working on this. The next thing you have is type AB. That means you have both A antigen and B antigen surface markers on the surface of your red blood cells. So if self means A and self means B, you're not going to make antibodies against either of those because you have both. So both are self. You recognize both, and both are harmless to you. So you don't make antibodies against those. So type AB, you have both sets of antigens, both types on your red blood cell surfaces, and you don't make any antibodies at all to other red blood cells. So type O, you have 0 surface antigens. That means that any antigen that your body encounters on the surface of a red blood cell is foreign to you because you don't have either one of them. So you have both anti-A antibodies against the A antigen and anti-B antibodies against the B antigen. So if you can think about self versus non-self as sort of the explanation for these antigens, it might help you to understand which ones have which. So to take it another step further, we're talking about who can give blood to whom. Okay, so that's the next trick in sort of answering these questions that you will see on your lab quiz and that you may see on the exam. So let's look at universal donor and universal recipient, and hopefully that will sort of illustrate the concept. So type O negative is the universal donor. So if I'm going to donate blood and I have type O negative, that means I have 0 markers on the surface of my blood cells. I don't have any antigens. So even if my blood, type O blood, is given to a patient who has let's say type A blood. Okay, so if I have type A blood, I have anti-B antibodies, but type O donor blood doesn't have any antigens on it. So it doesn't matter that there's anti-B antibodies because there's no B antigen on that blood, on that type O blood. So because the type O has 0 surface antigens, it's not going to cause a reaction in any patient that has any antibodies at all. So if you're type A, you can take type O because there's no B to fight against. If you're type B, you can still take type O because there's no A to fight against. If you're type AB, you don't have any antibodies anyway, so what does it matter? Just to get the type O and go on with yourself, okay? Go on with your life. So O is the universal donor. AB is the universal recipient. If you think about this, that makes sense. So if you have A antigen and you have B antigen, you're not making any antibodies because both A and B you recognize as self. So you don't have any antibodies to attack any donor blood at all. So that means you are the universal recipient. You can take any kind of blood because you do not have any antibodies to any of them. Okay, now the negative and the positive gets into the RH factor. So RH is a little bit different. We also refer to the RH factor as the D antigen. So in your lab manual, in your interactive activities, and in your lab quiz, you'll see that referred to as the D antigen. That's where the positive or negative comes from. So Rh positive red blood cells, people with red blood cells with the Rh antigen on their surface, it's the same thing as having the D antigen. If you have the D antigen, you don't have the anti-D antibodies or the anti-Rh antibodies. So it works in the same way. It's again just a surface marker that you have or you don't have. If you have the marker, you don't need the antigen, the antibody to that marker because it's self. So again, it's the same thing, self or non-self. Now, if you're Rh negative, you don't have that antibody. I'm so sorry, the antigen. You don't have the Rh antigen or the D antigen on the surface of your cells. So if you're exposed to that antigen, you will form antibodies to it. Okay, so Rh also works a little bit differently as far as reactions to exposure to that particular type of antigen. So with A and B, you have those all the time. So you already have, if you have type A, you have anti-B antibodies already formed. And because it's not the only thing that those antibodies protect you against, it's really working at that self and non-self thing. So you've already got anti-B antibodies if you're type A. And the reciprocal is true. So if you've got type B blood, you've already got anti-A antibodies circulating. So as soon as you get the wrong type of blood, you're going to see agglutination. Another thing I wanted to show you really quickly that might help is a picture of why agglutination happens and how. So let's go back just a second to thinking about A and B and O. So if you have anti-A antibodies, so this would be an agglutination reaction or a clumping reaction is going to happen when a donor is a mismatch to the recipient. So in this picture, this is actually showing agglutination by anti-A antibodies. So these anti-A antibodies are going to attach, they have double binding sites, so they can actually grab two cells that have A antigen on the surface of it. So what happens is these green anti-A antibodies are going to latch on to one red blood cell on this side and another on this side. They're going to connect at each of those different, it could possibly connect at each of those different surface antigens, those A antigens. And because they're grabbing more than one, they cause those blood cells to clump up. So agglutination or clumping reaction happens to the donor blood because the recipient has the antibodies against that donor blood if it's the wrong type. Okay, so in this picture, it's showing those antibodies, those anti-A antibodies clumping type A red blood cells. The only reason this is going to happen is if those anti-A antibodies are present, which means what type of blood must this person have had? Not A, right? So they must have been B with anti-A antibodies or O with both type A and type B antibodies. So hopefully that helps a little bit to sort of see what agglutination is and why it happens. So it's happening in the body of the recipient, but as a result of that donor blood. So the donor blood itself is what's clumping. Now those clumps, those agglutinated clumps of donor blood, red blood cells, are going to potentially clog blood vessels and cause hypoxia or lack of blood flow to the tissues, which can be problematic, even fatal. So that's where the problem comes in. Now with Rh, it's a little bit different, or the D antigen. You don't automatically have anti-D antigen in your blood if you've never been exposed to that D antigen. So if you are Rh negative and you don't have the D antigen on the surface of your cells, you do not automatically make anti-D antibodies until you're exposed to that antigen. So it works a little bit differently than the AB thing. So the first time you're exposed to the Rh antigen or the D antigen, if you are Rh negative, it's sort of like your immunization, for example, like with vaccines. So it's the first time that your immune system has encountered that. And so that you become sensitized and you begin forming anti-Rh or anti-D antibodies at that first exposure. That means that you're not going to see an agglutination reaction until the second time that you're exposed to it. This is why pregnancy and Rh factor can be an issue, because if you have an Rh negative mother, but an Rh positive father, you can end up with an Rh positive baby. If the mother's blood and the infant's blood mix, which sometimes they do if you have micro tears in the placenta or during the birth process or any number of different circumstances that can lead to the baby's Rh positive blood coming into contact with the mother's Rh negative bloodstream, then the mother is exposed to that D antigen, that Rh antigen from the baby's blood, and then the mother will start to produce the anti-D antigen or the anti-Rh antigen. So it's not a problem usually for that first pregnancy, because that's the first exposure to that Rh factor or that Rh positive, the Rh antigen. The problem comes in with subsequent pregnancies. So the next baby, if that baby is also Rh positive, then right off the bat, that mother who is Rh negative formed Rh antibodies during that first pregnancy. Those are already existing now in her bloodstream. Those can cross the placenta, and they do. And if you get anti-Rh antibodies into the bloodstream of an Rh positive infant who has that Rh antigen or that D antigen on the surface of its red blood cells, then those maternal Rh antibodies, anti-Rh antibodies, will start attacking the fetal Rh positive red blood cells. And that causes those red blood cells to be destroyed. That is where you get into what we call hemolytic disease of newborn, or abbreviated as HDN. It's also referred to as erythroblastosis fetalis. Same thing. When the mother's antibodies attack the baby's red blood cells. Now, without treatment, that will cause the baby to die in many cases. But luckily, there's an injection called RhoGAM that can be given to an Rh negative mother that can prevent her blood from her body from producing antibodies to the Rh factor if you know that it's an issue. So if you are Rh negative and you either do not know the baby's blood type or the father's blood type, or there's any chance that that baby might be Rh positive, if you are Rh negative, they'll go ahead and give you RhoGAM injections to prevent you from forming antibodies against your baby's blood, to protect that baby, but really to protect subsequent pregnancies from having negative effects from that blood interaction. So hopefully this has helped a little bit. Blood typing, I think, can be one of those things that gets really tricky, but just think of it as self versus non-self. We go back to the ABO thing. If you have the A antigen, you have antibodies against any other antigens. If you have the B antigen, you have antibodies against the other antigens, which in this case would be A. If you have both antigens, both are self, which means you have no antibodies against anybody. And then if you're O, you have no antigens at all, which means everyone's foreign. So you have antibodies against either A or B. All right. Hopefully that clears this up a little bit to where you can work with these types of questions on your exam. And that wraps up chapter 18 on the blood.